last week we looked at solution requirements, right? Part one, where we looked at the specification aspect of things. We looked at how to do use cases, how to write user stories, functional decompositions, various ways we use in actually specifying requirements, right? So today we'll be going down to part two, where we'll be looking at modeling in communicating or translating a requirement. It's what they call requirement translation. So we don't just stop at specifying, writing text to explain what we are saying, but rather we go ahead to model those requirements. And one secret and one truth I want you to take away from today is this: no matter the specifications you write, even though you write 100-page specifications, if you write the most detailed specification you can ever write as a business analyst, if you don't give a software developer a model, you have not completely communicated to them. Software developers or technical teams understand it better when you give them models, because the code that they write, the programs that they write, the software they write the programs for, those softwares are based on logic, and logic runs with models. So when you give them models, they can easily tie that model to a logic and that logic to a code. They are thereby building the solution as you have told them to build it. So have it at the back of your mind that no matter the amount of specification you are doing, as long as you are in a software development project, never forget to give them your models, to prepare models for the solution requirement. You can ignore design. They might not, another person might end up doing design. So in short, some developers, right, might go ahead to even build without you showing them a design, but a model is something that they can never, ever reject from you. So having established that fact, we'll be looking at what requirement models are. Do you understand? We'll look at requirement model. Why are they important, right? Why do we need to model our requirements, even after we must have specified them? We'll be looking at use cases, use case models. Use case model or UML use case is a modeling language that is used to show interaction between actors and system, or should I call it users and system. Then we're looking at data flow models or data flow diagram, and most importantly, looking at context diagram, which is an example of data flow diagram. There are different layers of data flow diagram, but we'll be looking at context flow diagram today. Then after that, we'll now wrap it up with process flow diagram, my models, process flow models. As the name goes, process flow, to show the flow of processes. So if you are doing operational improvements or business improvements or business reengineering, process engineering, reengineering, you need to show those processes. Let's say, for instance, you want to improve DHL's process of delivery, right? How DHL do their delivery. You want to improve it, that business. That's their delivery have a particular process. And the process has a way it flows, in the sense that it starts from here, it flows to this place, this next process occurs. After this process, the next process occurs. After this process, the next process occurs. So that's why it's called process flow. So process flow models, data flow models, basically how data flows in and around the system. How data flows, that's why it's called data flow. Why use case model means a particular scenario where actors interact with the system in question, how those interactions occur. So these are like the three key models that for every software solution you are building are core to those solutions. There are different types of, there are other models too that software developers also use. You have the entity relationship diagram, right? They call them the class diagrams. And the why business analysts are not really charged or taxed with designing those things now is because those responsibilities have moved to the database engineer. Entity relationship diagram basically talks about the database. What information, what data should be on the database, and how should those data be related to each other? That is entity relationship diagram, right? We have several models. If you go to Babok V3, you see a lot of models. But the beauty about it is that as much as we have so many models, these 3 models that we're looking at today are the core for every project you are doing, whether you are doing a software project or you are doing a process improvement project or you are doing a strategy, anything, you must use at least one of these project models when translating your requirements. So let's shoot and start right away. Requirements modeling. A requirement, as we know, is basically a statement that says what functions you want the software to do or you want the solution to do, right? It's just a statement. It could be a statement of need or it's a statement of to express what stakeholders need from a particular solution. When we specify the requirements, it is not sufficient enough or it does not give the complete communication that expresses the core attributes and capabilities of the system to all stakeholders. That is why it is very important for us to design models that will help to create a visual representative of the system capabilities and also create a visual representation of the system processes. And that is what models are for. Models helps to give that visual representation. When I write, maybe I list out the processes of probably people applying for a loan. I'll say number 1, the person will need to create an account with their email address and password, blah, blah, blah. Number 2, after creating an account, they'll confirm email. After confirming email, you have to select the loan type. Number 3, after selecting loan type, they have to fill the loan request form. After filling the loan request form, they have to submit, blah, blah, blah. When I write all those out, yes, anybody can read it and say, yes, this process is nice. But if I should model those things that I've listed out on a process flow diagram, then it makes a lot more sense. With just that model or that graphical representation, people can see end to end what it takes to actually apply for a loan or the process you are actually recommending that they should adopt. Some of the reasons why we basically model requirements are because models allow us to organize our data in multiple ways. Excuse me. Modeling our requirements allows us to organize our data in multiple ways. Models help us to see things that might be missing. Sometimes we might feel that we might have specified our requirement completely, and it happens a lot of times. You specify a requirement, probably you write your user stories, but by the time you start drawing a process flow diagram, or probably by the time you start drawing a use case diagram or drawing a data flow diagram, you get to realize that, oh, there are some things I actually missed out that I did not specify in my requirements. Then you can now go ahead to include those things or update your document with those information that you might have missed out. And that is because models help us to see some things that might be missing in our specifications. Models helps to create a visual representative of what is expected. What does our stakeholders expect from us? What solution are we expecting to build? The models we create help us to picture a visual representation or provide a visual representation of what is expected, of what the solution would look like. Models also helps to provide more analysis on the various components of the requirement of the system. So now imagine if you are doing your model, you realize that there's some process you did not actually capture in your specification. That gives you opportunity to even analyze those processes further, right? So model helps to provide room for more extensive analysis. Before you can correctly model your requirements, you need to ensure that you have done your specification because it's very important. You need to have specified your requirement to know how you're going to model them. So requirement modeling most times starts with your use case diagram Other times they could start with your context diagram, but it's most starts with your use case diagram, data flow diagram, then you go to your process flow diagrams, and then to your class diagram. Your class diagram is for the database. It's very, very technical. It's not something that if I should start teaching it today. In short, class diagram is something that could even take us almost 1 or 2 sessions to actually complete, because it's very, very, very technical. It's something that basically is database administrators or managers are learning, because it's very technical. So if you don't have that technical flair, don't bother going into disturbing yourself with class diagrams such as ERD, which is entity relationship diagrams. So let's start with the very first modeling that we'll be looking at today, which is use case modeling. As the name goes, use case, talking about a particular scenario, a particular use case, a particular instance, right? So it basically shows a high level overview of the relationship between actors. And actors in this situation could mean a user, it could mean the system administrator, it could mean another system, or it could mean a timing consideration. So it shows the relationship between actors, different use cases, and also the system. If you remember from our use case specification I talked about, whereby I showed you put the diagram. Let me go back to that so that I can refresh our mind to this use case diagram. It's always very important for us to refresh our minds on that aspect. So I'm almost there. So this is user story. Let me go to use case. Okay. Can you see my screen? Can you see my use case specification example screen?
Yes, I can.
Yes. Yes.
So this is use case, right? Title, this is a use case specification. This is when we are specifying the use case, right? The use case diagram is when we are modeling that use case. Now, all we need when modeling our use case diagram is to know the title of that use case, right? To know the actor or interfaces of that use case, to know the preconditions, and also the postconditions and alternative flow. And why do I say so? Because in your use case diagram, you're not bothering yourself about the basic flow or thereabouts, right? You're not bothering yourself about the business rules. The basic flow is good for you to have an idea, okay, after this use case occurs, or how does this use case occur? But in your use case diagram, you're not modeling the basic flow. All you are concerned about is the title of that use case. And that is why in your use case diagram, it shows the interaction between the actor, the use case, and the system. Or simply put, it shows how an actor interacts with the system. So what you'll be having in your use case diagram is just your use cases, your actor, and your system, then the relationships they have, the interaction they have. Do you get the point? So let's go back to the session for today. I just need to refresh our minds on that. Okay, so here we are. When you can see my screen, just let me know. Where can you see? What part of my screen can you see?
Use case modeling.
All right, fantastic. So UML use case models capture use cases and relationships among actors and the system. They help to describe the functional requirements of the system, the manner in which the external operators interact at the system boundary, and the response of the system. The manner in which the system, the operators or the actors interact with the system, and the response of the system. Use case diagram basically have 4 core components, right? And those components are use cases, actor, relationships, and the system boundary. Now, pay attention to these particular things I'm trying to put through. If you realize when we started the solution requirement and all, you always hear me saying things like format of writing this, the structure of these particular things, the template of this. how this thing is done. And the truth is that if you understand these formats or you understand these structures, no matter the tool you are using, whether you're using a Word document or MS Visio or PowerPoint or Lucidchart or Jira, no matter the tool you are using, all you need to know is that I understand what the basic structure of this should be. All I need to do is to understand how I'm going to use that basic structure. For use cases have four key components. Four key components. Number one component is the use cases, which I just showed you an example of its specification, use case specification. So in this use case, they are represented with oval shapes. They are oval shapes in your use case diagram. Anywhere you see an oval shape in your use case diagram is your use case, and is used to represent your functionality or the feature of that solution. That's why I realized in your use case specification, we have title. That title of your use case specification is what you write inside your use case. Let me give you for example. If in our use case specification now, the title of the use case specification is create accounts, right? You then will give a description. Talking about our use case specification, we give a description. Creating accounts involves, or this use case describes how a user or a borrower will create an account on the loan origination system. Then I'll give the preconditions to create accounts. Borrower must have a valid email address. Borrower must have a name and whatever. Then I'll now give the basic flow. The borrower will enter his first name and last name. Borrower will enter his email address. Borrower will enter his password, confirm his password. Borrower will click, or borrower will submit his credentials, blah, 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 blah. That is the basic flow. Then I'll now enter the post condition. Post condition is that borrower will be required to go and verify their email address, or email address verification is the post conditions. Then I'll give the basic, the business rules and alternative flow. Now, but when that is use case specifications, right? But when we are modeling our use cases, using our use case modeling diagram, that create account is what we actually write here. This actor becomes the borrower. So instead of writing actor here, we have borrower. Now, the relationship, I will put you guys through what relationships are. Relationship is how does the borrower interact with that create account feature or create account functionality. Then this system boundary is very, very important in the sense that this use case will need to be inside this system boundary to show that these are the features and functionality of the system. So this system boundary, this rectangle, the perimeter of this system boundary represents our loan origination solution. So when a developer sees your use case diagram, every use cases that are inside this rectangle, the developer knows that this should be the functionalities and features of the solution. And any use case or oval shape that you have outside of the perimeter of this particular rectangle, which is the system boundary, will not be considered as a feature or functionality of the system. So that is why we don't draw any use case outside of this use case, this system boundary. All your use cases will be inside this rectangle, which is your use case, your system boundary. So that is how we have all of that. We have the use cases to represent the features and functionalities. We have the actor, which is the user or an interface that is interacting with the system. Then we have the relationships. We have different types of relationship. We have generalization, we have include, we have extend, we have association. So relationships are 4 in number: generalization, include, extend, and association. So I'll walk you guys through all of that in the subsequent slides. So let's take them one after the other. Use cases, right? These are use cases. A use case basically describes a sequence of actions that provide a measurable value to the actor. That value that the actor wants to have, which is to create accounts, which is the features, which is the functionality he wants to perform, is what we consider as a use case. A use case is drawn as a horizontal ellipse, or you can call it oval shape, on a UML use case diagram. when drawing our use cases, these are use cases. You see, open accounts, deposit funds, withdraw funds, close accounts. From the look of things here, you can see that this particular features that this use case is talking about, or this particular value use case talking about, has to do with a financial process or a financial solution or a financial activity. Because when you say open accounts, deposit funds, the terminology fund alone depicts financial domain. So this is a use case or set of use cases talking about financial capabilities or financial features or functionalities or financial items in a process. And then we have the customer. Now, for drawing your use cases, there are key basic rules you should apply, which you should not avoid. I bet you if you bring 100 business analysts into a particular room or hall, and then you tell them to specify the requirements, they're going to specify the requirements very well. But the truth is that when you tell them to draw a use case diagram, I'm not trying to exaggerate. Nothing less than 60% to 70% of them won't draw the use case diagram very well up to standard. And that is because most business analysts ignore the basic rules in drawing your use case diagram. I was formerly in that particular position whereby my use cases were not actually well drawn until I took it upon myself to learn how to actually draw use cases, right? Until I now understood I've been making a lot of mistakes along the way drawing my use cases. So many business analysts, and I'm not just talking because of myself, even in my place of work, when I was training them on business and on use case diagram, a lot of them don't really know how to draw this. They just draw it because they feel this use case diagram, everyone can draw, but there are basic rules you need to apply. And it was after drawing it that they were all telling me that Genesis, we never knew these things were like this. So we never knew that we were supposed to not do this when drawing the use case. So adhere to these basic rules. It will help you wherever you find yourself outside planet Earth or within planet Earth. Drawing use case diagram, you will draw it as you ought to do. So some of the basic rules or rule of thumb for drawing use cases that when you are drawing your use cases, you need to name them with a strong verb. Start naming your use case with a strong verb. Why? Because your use cases represent an action. An action depicts the functionality or the features. Example is this: open is a verb. Deposit is a verb. Withdraw is a verb. Close is a verb. So use a strong verb to represent your use cases. Before, how am I draw my use cases? That was like 2 years ago. How am I draw my use cases? I will say account opening, or I'll say account creation. To me, even the developers understand that this is account creation feature, right? But I was not drawing it according to standard. I was just drawing it how every other person draws it, how every other business analyst draws it. Account creation, account this, registration, and all of that. Or I'll say, excuse me, I'll say user registration or account registration. So I basically draw it. Developers understand it because they know that this is what it should be. But if my work is to be measured by standard, it does not mean standard, right? So I had to take it upon myself to actually learn all of this. And I'm glad I'm sharing with you people. So start your use case naming with a strong verb. Begin it with a strong verb. Don't begin it with a noun. Don't begin it with an adjective or adverb or any other part of speech. Begin it with a verb. Open account. You can also say create account. Deposit fund. Or you can say fund account or fund wallet, because that fund wallet, that fund there is now a verb, no longer a noun. Withdraw fund. Close account, or you can say terminate account. So always start with a verb. Then the next basic rule is that you should name your use cases using domain terminologies. And When I say domain terminologies, ensure that the domain terminology you started with on your specifications are the same domain terminologies you use on your use cases. This will help anyone that is, excuse me, this will help anyone that is looking at your use case to understand the domain that the solution speaks to. Imagine if we are talking about, let's say, imagine if you are talking about a health solution, right? Or a health system. And then we are talking, you want to, for a health system, you won't say open account, right? What you'll be saying in this instance is create accounts, not open accounts. In terms of deposit funds, what you now say this is what make payments. Maybe you want to make payment for their medical bills. It will not be make payment rather than deposit funds. Or you can say pay medical bills that way, or pay bills. Withdraw fund, you can say something about collect drugs or collect medication. With that terminology of medication and all of that, anyone looking at that solution can easily know that this is a medical solution that you are modeling. Just as when you look at this, you can easily know from eyeballing it or from visual inspection that this is a financial solution that they are talking about. Another basic rule is that you need to ensure you place your primary use case in the top of the diagram. And what do you mean by primary use case? Primary use case are the very first use case that occurs in the entire system or the entire solution. What do I mean? We all know that the very first thing that most people do on a system, or very first thing that users do, is to create account. So it won't make sense for you to now carry this open account or create account and put it where you have close account, and then put your close account to become the first. So you have basically, you psychologically, you have rearranged those things. And anyone that wants to look at your use case and person sees close account, they say, how would they close account when they've not opened account yet, right? So it is best practice for you to place your primary use cases at the top first. Your primary use cases, let them be at the top, so that when people are ready, people can easily psychologically and mentally communicate and relate with the model you are drawing or you have drawn for them. Then also, you also need to imply timing consideration when stacking your use cases. Timing consideration in the sense that what occurs before the next. You basically don't withdraw funds before you deposit funds. You have to deposit before you withdraw, right? You can't close your account if you have not opened your account. So timing consideration, like in terms of what occurs next before the other thing, is also very important for you to imply when drawing your use cases. Now, let's look at some of the basic rules in actors. We'll look at use cases. Let's look at actors. Remember, we have 4 core components of a use case diagram. One is use case, the next one is actor, the third is relationships, and the fourth is system boundary. So we've looked at use cases, what they are, and what the basic rules and standards are when drawing them. Now let's look at actors. An actor on his own is a person, or is an organization, or an external system that basically plays a role in one or more interactions with your system. So they play a role, they have a relationship with your system. Some of the basic rules or standards when drawing your actors are: 1, first of all, you need to ensure that your actors are outside the use case diagram, that is outside the system boundary. Remember, I told you that the rectangle is your system boundary. Ensure that your actors are outside your system boundary. However, your use cases must be inside of your use system boundary. You don't draw use cases outside the boundary, but you draw actors outside the boundary. You don't draw the actors inside the system boundary, but you draw your use cases inside the system boundary. So please have that at the back of your mind. Draw your actors outside of your system boundary. Name your actors with singular business relevant nouns. Very clear. For your use cases, you start with your verb and then ensure that you have your domain terminology included. For your actor, ensure you name your actor with a business relevant noun and make it as singular. Rather than saying customers, just say customer. Rather than saying borrowers, as simple as possible, borrower. Don't go and start saying someone that will be buying something as the title of or as the name of your actors. Ensure it is a business relevance now. A good example is this. If you're talking about a medical solution, you won't go and be writing customer, you write patients, you write doctor, you write nurse, provided they are the one you are modeling on your use case diagram. If you're talking about an educational solution, you won't be writing patients, rather you'll be writing students or candidates or teacher or lecturer or professor. If you are talking about, if you are modeling, someone should give me an example of another business domain.
I don't understand your question.
Business domain, I'm talking about the medical, I've talked about the education. It was sectors. Okay, if you're talking about the social sector like NGOs, I want to model, you'll be talking about beneficiaries or last mile, right? Beneficiary or last mile or social implementer or funder, as the case may be. So ensure that your nomenclature for your actors is in line with the business domain you are modeling, right? That is very important. And then another business rule, or sorry, another basic rule or standard process you need to observe is that you need to associate your actor with one or more use cases. You can't have an actor that has no association, or should I say relationship, at any point. You need to ensure your actors have relationship, and that relationship that your actor have is what you call association relationship. Have that at the back of your mind. Actors have an association relationship. When we go to relationship, I'll explain different types of relationships. There are basically four types of relationship: association, generalization, extend, and include. For actors, actors don't have any other relationship with use cases except association relationships. Actors used to model or used to represent roles and not position. They used to represent roles and not position. Example is this. A role is business analyst, but a position is mid-level. So you are going to position. Position will be level 1 business analyst, level 2 business analyst. So in your modeling, don't have level 1 manager or level 2 manager. Talk about it, a manager, a manager. So actors help to model roles and not positions. Whenever you are talking about, or whenever an actor is a system or an external system or an interface, you ensure you use the greater than and less than sign to represent that. Example is here. So here is a system, an actor that is an external system but is interacting with our system in question. Because we want to ensure that it is a system, we have to use this greater than and less than sign to show that this is not a human actor, but it is another system. Is that okay? Then actors do not interact with one another, but they have one specific relationship they share. Actors can share a generalization relationship. I'll explain all of that to you when we get to relationship, right? Then last one is that sometimes you might be required to introduce an actor that is called time so that you can schedule your events or to initiate scheduled events. Now, let's go to relationships, which is the core of the matter, right? Because anybody can just draw use case, draw actors, and that is all. But relationships are very, very easy to miss out. There are several types of relationships that may appear on a use case. Number one is association relationship. Number two is generalization relationship. Number three is extend relationship. And number four is include relationship. Now, for extend and include relationship, all this, you see this stuff you're seeing here, they are all on your modeling tools, or should I say your any tool you want to use to model. They are all there. I'll show you guys a use case that use case shapes on Microsoft Visio. So you will see them all there. Now, an association between an actor and a use case is one of the relationship we have. Association between an actor and a use case. Another relationship we have is an association between two use cases. Now, that association between two use cases is what we divide into include and extend. Now, for include, see include as an example, which is when you are creating accounts, we must verify our email so that our account creation can be complete. Because let's say, for instance, include use cases talk about use cases that must occur next. As in, it is compulsory that the actor performs that use case next before he or she can perform any other thing. An example is when we create an account, we must confirm or verify our email address before we can actually say that our account creation has been completed, or before we can do another thing on the system. That is an include relationship. An extend relationship or an extend relationship between two use cases talked about when we have a use case that can occur, but the actor or the process or the system can actually go ahead without that use case occurring. Let me explain more in details. So let's say we have use case A, and then we have use case B, C, and D. If use case A and use case B have an extended relationship, it means that when use case A occurs, the next thing that happens is use case B. But we can actually choose to ignore use case B and go ahead with use case C and use case D. But the thing is that use case A will occur, use case B will occur next. But we can actually choose to ignore use case B. That's when there's an extended relationship. But if there is an include relationship, it means that when use case A occurs, use case B will occur. But we can't go to use case C if we have not done use case B, or if you have not passed through use case, if you have not satisfied use case B. As I mentioned, when you create an account, you need to verify your email. If else, your account creation has not been completed, or you won't be able to have access to the system features. But an example of an extended relationship is, let's say, for instance, you are buying something on Jumia. After you must have finished buying and making your purchase and making your payment, they will tell you to review share your experience or make your review or rate. That review or rating is what occurs next after you have made payment, right? But if you choose not to review, that does not stop you from still using the next available feature on Jumia, right? But imagine a situation whereby you want to make payments and you have not selected the item you want to make payment for. It means that you can't make payment, because if you don't select that item, they won't know the amount to charge you, right? Or you want to make payment, you've not selected your delivery options or your delivery type of delivery you want, right? So it means that selecting your delivery options or selecting your item is a compulsory use case that needs to occur next, after or during the process. But you can actually choose to ignore to provide your feedback or rate your experience or processes. So that is just an example of how include and extend use cases work. Now, another thing about relationship is that there is a generalization between two actors and also a generalization between two use cases. Generalization basically talks about, let's say, for instance, trying to see a very good, I don't use an example from here on the screen. I want to see how to bring about something that is a little bit more relatable. Okay, let me give you an instance. Assuming Moturayo picks up a call, right? And then calls an ice cream shop and says, okay, I want to buy ice cream. And they ask you to place your order, right? They ask you to place your order, place your order, place your order. When you are placing your order, right? Maybe let's not even do that. You call them. Let's assume you go to their website. They say that anybody that want to buy ice cream, whether you want to eat in the restaurant or you want to take it out or you want to eat elsewhere, you must go on our website to make your request, and then the ice cream will be available for you. So let's assume Moturayo is in the ice cream shop and Elsie is at home. Both of you want to lick ice cream. Elsie goes to the platform on their websites, or let me start with Moturayo that is inside the shop. Moturayo is inside the shop and Moturayo begins to, make her request what she wants. I want vanilla with strawberry and chocolate, blah, blah, blah. I want 2 cups or 1 cup, the quantity of the cup or the size of the cup, all those things begin to make. The Moturayo sees a place that they say, are you taking it out, or an option that say taking out, whereby if you should tick it, right? Whether you should tick you are taking it out or you are eating it in. But they just said if you just see that taking out option there. And Moturayo ignores it because she wants to take her ice cream there. So she did not tick that box. Then she submits. When she submits, they'll tell her, okay, your ice cream will be ready in 5 minutes. In 5 minutes, they deliver Moturayo's ice cream to her where she is in their shop on her table, and then she licks her ice cream, satisfied and happy. For Elsie now, Elsie is at home. Elsie will be feeling that same form that Moturayo feel. But when she gets to the point of, are you taking it out? She will click on yes because she's not in the office. She wants them to deliver it to her. When she clicks on yes, she will now see additional information that Moturayo did not feel because Moturayo wants to take her own in the shop there. Elsie is at home. She wants her to be delivered. So she will see additional information with respect to, do you want it to be delivered or you're going to come and pick it up? If she says delivery, she will now say, okay, they will tell her the cost of delivery. She should make payment for delivery. She will make additional payment. She will fill additional information. That is what generalization talks about in use cases. When two use cases are related by generalization, it means that we have actors, right? But we have a specialized type of actors who might want additional thing to what the normal person does. They are both making requests for ice cream, but there are additional things that they might want because they are specific in some way or they are special in some way. So that is why they need to put that additional information. So that is where the generalization between two use cases occur. So now let me go to this diagram I have here to use to explain to you, because I wanted to explain all of these so that when I'm explaining this diagram, it will be easier for you. Now, remember I said we have relationship between the use case and the actors, which is this. Now we have relationship between two use cases, which is include relationship. Here, when you enroll students, this is a student's registration portal, right? So when you enroll students, after enrolling, you need to enroll your seminar. So you've enrolled as a student, then you need to select your seminar or your courses you'll be taking, right? It means that after enrolling, the next thing you have to do, which you can't ignore, is to enroll in seminar. Now, also, these enrolled students, at the point of enrolling students, you can ignore and say that you're not an international student and go ahead to enroll for seminar. But if you are an international student, you will then need to enroll as an international student as well. Specify that you are an international student. So this is an extend relationship. It means that when you are registering, after filling this enroll student form, you will see another form that will ask you, are you an international student? If you click yes, then it will take you to that form to fill it. If you ignore or you click no, then you go ahead to register for your seminars or enroll for your seminars. That is the include and extend relationship, as I explained. Now, this enroll family member and enroll students are related by generalization, which I said here that a generalization between two use cases. This is a generalization. And what do I mean by that? When you are enrolling for students, in that student form you are filling, you can choose to enter the details of your family members or not. Just as LC, or should I say Motun, chooses to ignore what they call it, eating out, or should I say delivery for her ice cream when she's making a request on the page or on their platform, on their website. So this enroll family member is related with this enroll student in a generalization relationship. Now, this is a generalization relationship between students and international students. What it means that these international students, they do all the things that students do, but because they enroll as international students, they do something specific, unique. That is why we bring them aside to show that, okay, this is the specific thing they do. Nonetheless, they also do every other thing that normal students does. A good example is this. So we have borrower. Assuming if you loan origination solution that you guys are working on, your own particular one, you say you want to use two type of users. That users, I mean, the two type of customers, individual borrower and MSME borrower, right? They are both borrowers. Now, you can agree with me that if you are to fill a form, an individual borrower will fill his personal information, financial information, and his loan request information, right? But for an MSME borrower, MSME borrower will fill his personal information, financial information, business information, and the loan request. It means that the MSME borrower is filling an additional information or is performing an additional function on the system that the individual borrower is not performing. So when drawing your use cases, you have your individual borrower and you have your MSME borrower. And both of them will be linked by a generalization relationship. What that means is that all of what the individual borrower does is what the MSME borrower is going to do. But there are some specific things that they will do that the individual borrower will not be doing. Just as a national student will be filling international information. Only an international student that will be providing their international student information. So now let's go to the basic rules when we are drawing relationships, right? When drawing relationship, you need to avoid arrowheads on an actor use case relationship. You need to avoid more than two levels of use case associations. What this means is this. You see these associations, 1, 2. Don't go ahead and having about 3, 4 associations with just one use case. You need to avoid it. One association with this is enough. Then another one is place an included use case to the right of the invoking use case. What does that mean? This is an include use case. When placing your include use cases, place them to the right of the invoking. The include use case is actually coming from this enroll student. Place it to the right of the invoking use case. Also, that goes for our extend use case. When drawing our extending or extend use case, we need to place them below the invoking or parent use case. So this is an extend use case. We place them below the parent or the invoking use case, which is enroll students. The extend use case here is enroll international students. We place it below the parents use case. And if you should watch the way their arrows are, the arrows of include use case is going from the parents to the include use case. But for the extend use case, the arrow is coming from the extend use case to the parent. So it's pointing to the parent. But for the include, is going to the include use case. Please take note of that. Then place an inheriting use case below the base of the use case. So this is an inheriting use case or a generalization use case. You place it below the base of is inheriting or parent use case. And then finally, place an inheriting actor below the parent actor. So we have an inheriting actor here. This international student, it inherits everything that this student does. But because it's a special category of students, they have some things that they do that the parent actor will not do. So you place them below the parent actor and you draw their arrow upwards. So that is it about relationships. Let's go over to the last one, which is the system boundary. So the rectangle around the use case is what we call the system boundary. Sorry, I did not draw the rectangle, but I believe rectangle is also is clear to us. And as the name suggests, it indicates the scope of your system. Everything inside the rectangle are things that talks about the system. That's everything in terms of use cases. Any other use case that is not inside the rectangle cannot be considered as functionalities or features or activities that occur in the system. So that brings us to the end of use case diagrams. I want to open my Microsoft Visio so that I will show us use case. I hope I have this use. I have a set of use case diagrams that I've drawn open. If not, maybe I'll have to draw one for us and share with us later because the process of drawing now. Okay, thank you. Thank you, Motunhayo. I'll try and take water. Okay. My Microsoft Visio is opening. Oh, so these are process flows that I drew. I can't remember when I drew this process flow. It's been a long time. Delete account, set up bills, blah blah blah. Don't be scared. It's just a normal process flow diagram with a flow chart. Let me keep this. I'll walk us through it when I'm drawing, when we get to the point of process flow diagrams. Let me go back to my Visio. I should have a use case diagram that I've drawn before. Let me check my view if I have. This is my personal laptop, so it's not my office laptop. My office laptop, I'm sure I have all these things in my office laptop. But nonetheless, let me just show us a use case diagram, how it looks like. So these are Microsoft Visio. There are different tools we use in doing our models. We have Visio, which is the legacy or most common type of modeling tool we have in the world, Microsoft Visio. And we have Lucidcharts. I'll also show you guys Lucidcharts. We have diagrams.net. Lucidchart and diagrams.net, you can use them online, right? But for Visio, you have it on your system. You have to download and install, and then you use them. For you to actually draw use case diagram, you go to. Can you see my screen? My Microsoft Visio screen. It looks like Microsoft Word, right? And that is because it's from Microsoft. So we have different things. This tool, you can't learn it. You can't learn everything about this tool today. This Microsoft Visio, but it's something you sit down and learn. If you want to be a good business analyst, this has to be your best friend in terms of modeling, right? So we have the insight as we have it in Microsoft Word. You have insert, you want to insert shape. You have draw, you want to select your draw tools and all of that. Design, you want to design your diagram. Data to import or get more data. Process, you want to validate a particular process. Review, you want to review your work. View, you want to change your view shape and all of that. So let me go back to home. We have the normal formatting things we have on our Microsoft Word, right? Just as the filling, which is color, line, which is the border line, tools, text, if you want to insert a text, if you want to use a connector. Connector here is called a relationship. In Microsoft Visio, relationships are called connect, sorry, not relationship, flow. If you want to link two shapes together, you use connector to link them. And if you want, let me show you for instance. You see the way my mouse pointer is. You can see how my mouse pointer is, the way it is, the shape of my mouse pointer. There's like an arrow, a curved arrow underneath. For with it, I can draw a connector. I can draw as much connectors as I want. But let me Control Z. If I should go back to pointer, it gets to a point whereby I can now choose or hover around. That is it. So you can choose. If I want to change my mouse pointer to become the shape of a text, I can put this. That my mouse has now become the shape of a text. I can draw this to create a text box and I begin to tap on it. So let me go back to pointer. All right. Let me go back to pointer. On this pointer, please, I can also choose different shapes I can have here and all of that. But let's go straight to use case diagram. To draw a use case diagram, I'll go to more shapes and then I'll look for use case diagram, right? So go to more shapes. From more shapes, go to software and database. From software and database, I'll go to software. And that is because the UML use case diagram is used in modeling solutions, and solutions are softwares. So go to software, and then when I go to software, you see all different types of use cases. You see data flow diagram shapes, enterprise application. Let me unselect this. Let me unselect this as well. Okay, let me leave this for now. Then I'll go to UML use case. Can you see UML use case where my mouse is? LC Motunrayo, are you put there with me?
Yes, I can see. Yes, I can.
Yes,
Yeah, so this is your UML use case. So you click on it. Once you click on it, it has ticked. It shows that it's active and the shapes are there. So I have the shapes here. These are my shapes. This is the actor. Let me zoom in so you can see it properly. So this is the actor. This is the use case. This is the subsystem, the rectangle I told you about. This is your association, which is a type of relationship. This is your generalization, a type of relationship. See the difference with them. Your generalization has an arrowhead, but is unique arrowhead. This is your extend relationship. This is your include relationship. Then this is your dependency. This one is no longer, it's rarely used. Rarely used. It's basically showing a feature that is dependent on another feature, right? But it is rarely used. Most times we just use our include or extend to depict it better. So all of those shapes I've been telling you guys about, this is it. Our use case diagrams have 4 core components: your actor, your use case, your subsystem, and then your relationships, which you have here. These are your relationships. This is your actor, this is your use case, and this is your subsystem. Let's draw a very simplified use case diagram, right? People agree with me? Or we should just go over to the next one, which is context diagram.
Please draw. Please draw.
All right, so let's draw a very simplified use case diagram. Let's use your loan origination portal, for instance, right? So the first thing is, let's talk about the system, right? can increase the size of my system. I can reduce it. So talk about the system. The name of the system is what? So I'll click on this name, double click on it, and I write loan origination solution. That's the system. I can choose to do the usual formatting of making it centralized, right? Make it centralized. I can choose to bolden it, make it bold, and then increase the size, right? So these are loan origination solution, isn't it? Now, we have an actor here who must be placed outside, right? And the actor here, let us call it the borrower, whether individual or this. Let's not go into specifics. Now, let us say borrower. Is our borrower, right? And then what are the activities or functions that the borrower is going to perform? So we bring our use case. Now, this use case here means that these are the activities that will be performed on the solution. If I mistakenly take this use case and place it outside the system, any part of the system I place, means that these things are not, as nobody will consider it as anything as part of the system. Do you understand? So I have to take it and place it inside the system. I can choose to place it at this point of the system, or this point of the system, or this point of the system, anywhere, but it must be inside the system. So I have what? Create accounts. Right? Then I have, let me just come up with some use cases. Verify email. That verify email. Fill loan requests form. Submit loan requests. Right? Then another one will be what else I can do? Track loan progress or status. Right. So let's just use this 3. Let me bring one more, which is login. Right. So I have my use cases. Let me increase this size of this stuff so you can accommodate. So you have create account. And as I said, most times our verify email is always an include use case for our create account. So place it at the right of the inheriting use case. We have login. We have fill loan requests, right? We have submit loan requests. Another one I want to include here is confirm submission. Right? Confirm submission. Right. So track loan status. So now let's begin to put our relationships to this. Remember, the actor have an association relationship with all of the use case. So I'll take this, bring it here, and then I'll draw. And make this a bit more neater. Then for this will have what they call it, an include relationship with each other. So I'll just take an include, bring it here, and join them. Oh, what is this doing? Bring this guy here. Draw it here. Draw it here. So you can see it include. You can see it, right? Include. Then the next one is the association between. I can come here, Control D to duplicate. Put this here and place it here. Control D again to duplicate. Place it here and place it here. Then move this down a bit. Control D again to duplicate. this is here, this is here. Then Control D again to duplicate, placing it here, placing it here. Now this also has an include relationship because when you submit your loan request, you need to confirm your submission, right? This is here, this is here. So something else, I just remember that there's so many functionalities or activities that can occur. Another one will be review loan application. You can review your loan request form, what you have filled, to review it before you submit. So that if that one should come in, that will be between fill loan request and submit loan request. Now, let me bring in another type of borrower from here. Let's say this is individual borrower. I want you to explain the relationship between actors and actors, right? Let me bring this one down. Right? Let me put log out here. Okay, let me make this more specific. View loan status dashboard. View loan status dashboard. Let me make this to be here like this, so it will be easier for me. Okay. So view loan status dashboard, then log out. Just put log out here, because you also need to log out, right? Now let me bring in another type of borrower. And I'll call this, that's for those of you that are using two types of borrower, MSME borrower, right? And what is that specific thing that MSME borrower will do, or should I say they do? One of that specific thing they do is provide business information. Provide business information, and they have an association relationship for that. So they have an association relationship for that. And it means that what this is that this MSME borrower can do all these things that the individual borrower is doing. So for that, I'll use a generalization relationship. So it means that the specific thing that an MSME borrower will do that this individual borrower will not be doing is to provide business information, right? So that is just it. So this is like a typical example of a use case diagram. Let me complete my stuff. From this, we can see that the MSME borrower can log in, create account, verify email, fill loan request form, submit loan request, track loan status dashboard, log out, and do an additional thing, which is to provide business information. Now, I can even bring in another actor, because for this solution, there are different types of actor. I can bring another actor, and the actor is system
admin.
Yeah, system administrator or system admin. Let me leave that system admin. That is another actor, right? So my system admin. What are the things that my system admin will be doing? System admin will be logging in, right? System admin doesn't create an account for himself, right? He logs in. You log in. System admin, what are other things he will do? We will configure the system, right? System configuration. Right? You configure the system. Another thing we'll be doing is user management. We'll manage the users on the system. Right? Then another thing we also do is loan management, to manage the loans in terms of approval and all of that. Right? So this is an example of typical use case diagram you can have out there, talking about your use cases and what they do. So let me duplicate this, Control D. Bring this here. E, bring this here. E, bring this here. So in less than 10-15 minutes, we've drawn a hypothetical use case diagram of the loan origination solution that people are working on. Looking at the individual borrower, the MSME, the system admin. If your borrower is only one borrower type, which is individual borrower, they don't need to show this MSME. Do you understand? And then you can also have, if you don't want only your system admin to be approving, to be the one in charge of approving and disbursement, you can have a disbursement officer separate. Do you understand? Disbursement officer. You can have him here. So depending. So depending on what you have specified, and that's why I said it's best for you to start from the point of specifying your requirements, then you model them. If in your specification you have stated several things that should occur, then you now begin to model them. Now imagine if you give somebody a 5-page document of a use case specification, use case specification about 5 to 7 pages, saying a lot of things about the system. You give it to a developer, and then you give another developer a 1-pager use case diagram, which even says everything about that solution, but graphically now in a diagrammatic format. They will end up appreciating it because with just this 1-page diagram, they can see all the capacities and capabilities of the system. They can see all the activities that need to be performed by different actors, rather than you spending 7 pages, 10 pages, 5 pages writing about what the borrower will do, what MSME will do, what system administration will do. So that is why developers appreciate models a lot. It helps them to save time. It helps them to understand the system better from the technical point of view. So this is a use case model, a typical example of a use case model. I don't know if you have any question before we go to context diagram model or data flow diagrams or data flow models. Elsie, Motun, any question?
Wow, I have. Thank you very much for this. It's also possible for the system admin to be an individual borrower, right?
So the system admin is not an individual borrower. System admin is the one that manages the system.
What I mean is that he can also act as an individual borrower in as much as he manages the system.
Is he also borrowing? Is he borrowing? Is he borrowing? Is he collecting loan?
He can also collect loan, right?
So if he's to collect loan, he's termed a borrower. So you have specified all of these things in your specification. A borrower is someone that requests for loan. And the system admin is someone that manages the system. You get the point? So let's say, for instance, now you are the system administrator and Motun is a borrower. If at any point in time you feel like, there's this business I want to start, let me also apply for loan, you have to go on the platform to create an account, right? And create an account, you verify your email and all of that. So at that point, you are seen as a borrower. That's why I said that your actors does not specify position. It specifies role. So if you are performing activities of a particular role, you are that role. Let's assume Motu, who is a borrower now, Motu gets employed by Optrust and she's a software developer or thereabout, and she knows how to manage the system. And I say, okay, Motu, you know you've been borrowing loans from us and you are working with us. We want you to be the one to manage the system. Become the system administrator. The role of Motu now becomes system administrator. You get the point? So anybody can borrow loan, even the owner of the company can end up saying, okay, let me borrow loan and share from my own investments. But the fact is this, when it comes to use cases, you're talking about roles and not position. You get the point now? So they get that clear. This is what a borrower will do. Whether that borrower is someone that's I'll be managing the system, or that borrower is of the business, or the borrower is someone in the street. Anybody that is a borrower, these are the things he's going to do. And anybody that is a system administrator or system admin for that solution, these are the things that he will also do. Is that clear? Elsie, are you there? Hello, Elsie.
Yeah, hello, I'm here. It's clearer now.
Okay, thank you. Mosun, you want to talk?
Yes, I want to talk. And what I want to ask is that for this diagram, are you saying that the system admin is a vital force, in everything, in whatever solution we are doing?
Okay, thank you for that. So, if you remember, when it comes to systems or solutions, we have someone who is in charge of it, who is an admin of it, right? He's a person that basically configures the system. Configuring might be through code. Configuring might be to set up. That's to set up the system, right? He's a person that is in charge of updating the system. That's another function here. Update system, right?
Okay.
He's a person in charge of updating the system. If the system is down, he will be the one to, fix up the system. So he's a system admin, right? But we need to be careful in our use case because you're talking about what the system admin performs on the system or how he or she interacts with the system. So a system admin comes in when you have actually specified that there should be a system admin. But the truth of the matter is that you can't have any system without somebody managing that system because softwares fail, right? And they will need someone to actually resuscitate, to update, to work on them. So you actually need to have a system admin. Do you understand? It's just like let's say for instance now, let me give you an instance. We have a coffee shop or we have an ice cream shop, as I mentioned, right? We can't have an ice cream shop without somebody being the one preparing the ice cream. Even though nowadays we have machines that are okay. Let me it's even simple, fantastic. So if now things have become so automated by some machine or coffee shop, we have a machine that dispenses it, isn't it?
Mm-hmm.
Now, if the ingredients that are supposed to use to prepare a machine or to prepare an ice cream or dispense an ice cream has finished, who will put in those systems is the controller, right?
Mm-hmm.
The person in charge of managing, ensuring that ingredients have not finished, or maybe the machine have not run out of ingredients, or maybe if the machine is faulty to service the machine. That person is seen as a system administrator when it comes to solution or software. Do you understand? So what is the relationship or interaction of that person with that particular machine or that particular solution? One of the interaction will be to refill ingredients on the machine, right? One of the interaction will be to service the machine, right? Or responsibilities or activities of that person. Yeah, activity is the best word. One of the activities of that person will be to refill the ingredients, service the machine. One of the interaction will be to also monitor the productivity of the machine, right? So that is what the system admin stands for. So you can't just say because I have a coffee machine, I will not want to learn how to, manage it or ensure that it's performing in an optimal state. You get the point?
Okay, thank you for that. Another thing I want to ask is that our system admins always attached? Do they come from the do they work in that organization, or is there any third party that is assigned, or third party company that is assigned to monitor the system?
Okay, fantastic. That's a lovely question. So the thing is this, it can be either ways. A good example is this. Let's say, for instance, now you own you are Jumia, and I'm the one that built this your e-commerce solution for you. You can choose to say, okay, Genesis, after building this solution for me, I have somebody in my company that can manage the solution. I've trained that person. Or after building, I need you to train somebody that will manage it for us. That person that will be managing the solution for Jumia is a system admin within Jumia. Jumia can also say, oh, okay, since you build the system, we don't want to go and start incurring the cost of managing it ourselves. And then whenever there's a bigger problem, starts troubleshooting to you. We want you to manage this system for us. So system admin, it depends on the agreement. There's what they call SLAs, contracts that have been signed. It's at this point that it's at the point of SLAs that we're going to have all of these things clarified. And another situation is this. We can have normal system admins that are not technical inclined in the sense that they're not developers within the company that owns that solution. But we can also have a technical system admin that knows software coding or is the one that actually built the system. Are you getting now? What that person will do is that if there are technical things, he or she will call me. But if they are just trivial or minor bugs or issues on the system, that person that is not so technical can actually fix it up. A good example is this. Let's say we've built an e-voting solution now for ICANN. ICANN have their IT department, right? After building, who will be managing the ICANN solution? Is the ICANN IT officer, or maybe their head of IT or their IT team that will be managing that particular software. They are not the one that developed the software. We just built it and gave it to them because they're IT personnel, so they know how to manage systems. So they're the system admin, right? But if at any point in time we now have maybe complex issues, maybe the system needs to be rebuilt, or maybe an additional functionality needs to be done, or maybe there are some data that the system, that the ICANN IT person might not be able to retrieve from the system, and it requires a lot of coding, then the software guy can come in. That is why nowadays we have different types of system admin. We have just the normal system admin, and then we have what they call super admin. That super admin must be someone that is a software developer, must be a software developer who knows how to, go to the back end and get information when things are difficult. But the system admin is basically someone that can just, do configuration, set up, and all of that on the system. Is that okay? So nowadays we have super admins. Is that clear enough? Or I should go ahead to explain further?
Well, it's clear, but you can explain further. The more we know, the more insightful it is.
Okay, so let me give you an instance. Still with the coffee machine, right? Or the ice cream machine. So we have someone within that organization that is in charge of, let's say, fixing or repairing the machine, refilling the machine. Let's say refilling the machine, imputing the number of cups you should dispense per hour, right? Maybe 100 cups per hour or 50 cups per hour, depending, right? Now, that is the person doing the setup, pressing the button on the machine to set up and configure the machine, right? Now assuming that, let's assume that one of the cup got stuck inside the machine. Or maybe the person have actually set up the number of cups and the level you should be filling up the cups, but the system is not responding to the setup or the configuration the person about that the person to manage their machine have already set on it. That will now require us to now lose the machine, right? We bring our spanners and everything. If that person that is doing the setup doesn't know how to lose the machine, take screwdriver to take out the screws, take out the bolt and the nut. If that person is not skilled in that means we now look for maybe someone from the manufacturer to come down to our shop and then open all of that and then bring out that cup or see what's actually making it not to respond to the configurations that we have set on it. Is that okay? So now picture the non-technical or less technical system admin as someone that is just in charge of pressing the button to set up and configure. And then picture the super admin as someone that is from the company that manufactured that machine, maybe from, let's say, maybe from Hayata, right? Or from Samsung or from LG. Is that okay?
Yes, it's okay.
Okay. Any other question before we go to context diagram?
Yes, I have a question on where generalization comes in.
Oh, fantastic. Okay, go ahead.
Yes. The generalization is do we have it? Sorry, please. Do we have it in this diagram?
Yes, this is a generalization relationship.
Okay.
What I just clicked on.
Okay,
Yeah.
so the generalization relationship is basically the exclude and include, right?
Nope. See generalization. See where this way I'm clicking. See what I'm
Okay.
clicking. Now watch how this arrow is. Arrow of the generalization relationship. See how it is. And see the arrowhead of include and extend. See how the arrow is. Do you understand? So,
Yes, I do. Okay.
and again, they are all include and extend is titled. You see it include, just as we have here. When I was showing you the shape, you see extend. You see it titled extend. Do you understand? You see include. You see it titled include. But for generalization, it has no title. This association. Association has no arrowhead, I mean. It has no arrowhead.
So the generalization is basically the relationship between the actors or use cases.
So association is relationship between actors and use cases. As you see here, you watch, this arrow has no arrowhead, right? It has no arrowhead. That's why it's an association relationship. Do you get the point now? Relationship between actors and use cases are association relationship. Association relationship, which is this one. Association. You can have generalization between actor and actor. You can also have generalization between use case and use case. Do you understand? You can have generalization between use case and use case. In this situation, if I want to draw a generalization relationship for this, it's going to be between this provide business information and fill loan request form. Because providing business information is part of this. So if I want to draw it here, so that to make the work a bit rough and all of that, I can come to this place and let me see. If I want to draw it here, I can just move this one to this place here.
Sorry, please, if you want to draw what, let me get it. Sorry.
If I want to show the relationship between this and this, it's going to be generalization relationship. Do you understand? Between this and this. Why? Because
That's
I said
between use case and use case, right?
yes, generalization occurs between use case and use case, between actor and actor. Do you understand? Let me repeat. Generalization occurs between use case and use case, or between actor and actor. Do you understand? Then association occurs between actor and use case. Do you understand? When I share the slide with you people, you see it there. So there's no need to start cramming it now. When you go over the slide or you go by the session again, you will see listen to all of this again. Is that okay?
Yeah, it is. Thank you very much.
And then with constant practice, you get to know it. You don't need to cram.
That's fine. Thanks.
All right. Let's go over to data flow models.
Go over to data flow models. I want to ask, how long will it take for someone to really, put all these things you have taught us from the beginning to this user case into to implement it and become very good? Because I'm beginning to have a heart part.
Okay,
I'm not joking.
Even me, honestly, Moto,
I'm
I'm
not
just
joking. I'm not joking.
I'm
You've really
sobbing.
taught us. I really appreciate and I thank God I'm in this thing. But at times when I want to do my assignments, I'm having a panic attack. I was like, God,
Yes.
when I will like get and become guru and I will understand and know these things that it will be part of me. When someone wakes me up, I can do it, without baiting an eye. But I don't know. That's why even with the way my body is, you see me still being on this, I just can't sleep. God forbid I will have an attack. So let me just be looking at it the way I'm looking as you're teaching me, But when or how long will it take someone to become, you be sure of yourself that you know it? How long?
Okay, thank you for that question. Thank you so
And
much for
I
that question. And the beauty of this, I was once in this
I still
situation
want
you
to
are.
stop. Let Elsie talk. Oh.
Soraya, thank you very much for that, honestly, because during the trainings like this, we understand it better, but assignment becomes a struggle. And I try to relate the assignment with what has been taught. Like for today, I'm hearing about requirement models or modeling. So I'm really struggling with trying to comprehend all these and put them into practice. So I don't know, like Motorayo is suggesting, how long really will it take us to be a guru in this, even as we have constant practices around it? Thank you.
Okay, thank you so much for the question. Let me start with Motorayo. Um, First, I'll answer it in different ways. First of all, I want you to know that I was in this situation before. I've been through this situation. I did not study computer science in school. Even my first job when I started off wasn't in IT. I was basically doing, I was working in the social sector, NGOs. That was where I was working. So my first set of jobs after years of everything, in short, I was even working I was working in a publishing firm as an editor at some point. So to show you that I didn't go to school to learn this. But the beauty of all of this is this. There was something that someone told me long years ago when I was a young man trying to write WAEC, write JAMB and all of that. So the man told me that Genesis, when you are approached with difficult things that requires you thinking, that requires the use of brain, right? You're approached to solve a problem or to, attempt something that requires you to think. The best way to remember or the best way to become better is to start from anywhere. As in start from anywhere. Let's say, for instance, now you're in the exam hall and you see a question. You'll be trying to see how to remember it, to remember the exact answer, and it's not coming. The best way is start by anywhere. It might be by start by writing the question. Maybe by when you're trying to write the question, you remember one particular terminology that was said in class, and you start writing that thing that was said in class. From there, you remember everything, or you remember some part or portion of it, and that helped me a lot. That secret helped me a lot, even while I was in school. You have all of these things. Yes, when I teach them, they are clear to you, but when you are faced with them, it looks like, where will I start from? Can I do this? That is one of the primary, or should I say, the most important victory you can have if you can overcome that initial fear. That initial fear, because the fact is that you feel like, I don't want to make a mistake. But the truth is, this is an opportunity for you to make that mistake. Make that mistake. You can't start and be a guru in one day. You must make mistakes. And you make mistakes by attempting. I made mistakes. You can, if you listen very well, during the point of I said before, I used to draw use case diagrams, and I felt I was drawing them well. Until I had to relearn how to draw it properly. And that came as a result of me associating with people that are higher than me in business analysis. And I was like, I want to relearn how to draw this appropriately standard. So be open to making mistakes, because it's in mistakes that you'll be corrected, you'll be guided, and you will learn. So don't think of, when I start now, I'll get it. I should to get it perfectly. No. Nobody starts to learn anything, especially something that is alien to you, something that you don't know, and you become a guru at it. Is it to cook? Maybe you've never cooked in your life. Or is it to sew? You've never sewn a dress in your life, and you want to get it perfect the first day. No. Even people that learn sewing, that's fashion, they tend to start with paper or doll baby, all of these dolls or paper. Because when you are doing all these things, you're going to make mistakes, and it's good for you to make those mistakes. Mistakes are the most important part in learning. You can't become good if you've not made a mistake. So attempt it. Overcome that initial fear of, I don't want to make a mistake. Hope I won't get it wrong. Get it wrong. Do it. Then when you get it wrong, I've done it, you learn from it. You continue again. You get it wrong, you learn from it. And that is a platform that this provides. That's why I give you that project. Other people will just train you all of this and teach you all of this. And maybe you understand them. But when you get on the job and these things encounter you, you'll be blown away. You'll be blown away. But I give people the opportunity to work on a project, to actually learn and to try and practice these things, to make that mistakes. Let me correct you. Feel free. It might be cumbersome, it might be a Herculean task for you, but be ready to make mistakes if you actually want to be a guru. Simple. Now, the amount of attempts you make will determine how fast you become a guru. Example is this: that that stuff whereby you throw that to get to a center of whatever. The first day you might throw it, you might be lucky and by luck and you get it. But for you to consistently get it right, you need to be throwing it every day, every day. Same thing with any type of game. Is it snooker? Is it Ludo? Any game, anything in life that we want to learn. The amount of attempts we make will determine our speed to becoming better at it. That is it. You want to learn high jump, you want to learn running, you want to become a fit farm, to be doing exercise. At the first day, it might be difficult. Second day, your bones will be aching, your muscles will be aching you. But the number of attempts you make will determine how fast you'll be able to get used to that lifestyle that you are adopting. So I can't tell you that it will take you 1 year or 20 years or 5 days or 1 week to become a guru. But the thing is that it's your number of attempts. You fall, you rise. You make a mistake, you learn from that. And the beauty about it is that when you make a mistake, and you learn what is right from that mistake, you will never make that mistake again. But if you have not attempted to make that mistake, you will never learn what is actually right. And you can actually evaluate your capability or your capacity. So attempt. Overcome that fear of, I don't want to make a mistake. I don't want to get it wrong. I don't know where to start from. Start from anywhere. Attempt. I'm not a tyrant whereby I'll shout at you. This is not a project that's there's revenue attached to it, because the fact is this: when you get a job, revenue is attached to whatever thing you are doing. And if you get it wrong, it's impacting on revenue, it's impacting on the time of other people, it's impacting on the project. So this is the best time for you to get it wrong and get it right and be corrected on what is right. So make attempts. Don't be afraid, make attempts. Get it wrong. It's very good, because I got it wrong several times myself. So I did not become a guru in one day. I got it wrong multiple times. And I said I was not going to give up on myself. So be ready to make attempts to get it wrong. And you realize that as I said, number of attempts you make, if you say to yourself that this data flow, this use case diagram now, I want to learn it. You can draw about 20 use case diagram in a day. By the time you finish drawing 20 use case diagram in a day with this session we just had for over 1 hour, 30 minutes, by the time you draw over 20 use case diagrams, you must have understood at least 70% of how to draw a use case diagram. Or maybe you draw use case diagram 10 times, and in those 10 times, you're giving me to review for you. After the 10th or 20th time, you must have known how to draw it at least 70% or 80%. So the number of attempts you make will determine how fast you are to becoming a guru. That is just the answer to your question.
This is very encouraging. Thank you.
You're welcome.
Thank you so much. And another thing, after this class, do we still have access to you, still while we are still developing ourselves and all? Because those are the things I used to worry about.
Yo-Yo and myself, me and Yo-Yo still talk to today. Chioma, we still talk to today. So there was someone that did the training last year. Ayodele, he's in Canada. I don't know what part of Canada is. He's doing his MSc, what they call it over there too. So he chatted me up 2 weeks ago and said that Genesis, he wants to refresh himself on some things. Am I available? I said to him, yes, I'm available. I'm available. And he chatted me up. Then I told him to chat me up on Teams. He chatted me up on Teams. We reconnected. So I'm always available for you.
Okay, so it means that even the materials too, even if we complete our project. Hello, can you hear me?
Yeah, I can hear you.
Yeah, does it mean that even when we complete our program, we still have access to the materials on Team?
Yes, so the recording is available to you. Do you understand? The recording is available to you.
Or emails too.
Your email is also available. I'm not freezing your email. Let me show you an instance. Close the door now. Let me show you something. Let me stop recording and show you guys something.